This is a video tutorial to set up and analyze a complete simulation of a high-pressure die casting process using Click2Cast. The first step is to import the geometry of the part. Click on the New Project button on the left toolbar. A pop-up window will open, select an STL file and click Open. Once the file is opened, in your right-hand side toolbar, click on the Mesh View button to show and hide the STL mesh. In this toolbar, you'll find different visualization options such as Rotate, Zoom or Zoom Frame. You can measure a line by using the button Distance and selecting 2 points. And other options you will also find on this toolbar are Create or take a picture, change to different views, and change the color of the geometry. Before going to the next step, it's necessary to define the measure units of your model. Once the units has been selected, we are ready to continue. In the stage 2, the ingate and the mesh will be defined. Click2Cast allows a user to define the ingate in 2 different ways: the automatic option, selecting a surface directly over the part, or the advanced configuration option. The advanced tools allows you to create a square or circular ingate. Just select the orientation, make a click on Add Ingate button and select the position of the ingate in the part. In this case, the size of the ingate is not well defined, so let's proceed to delete the ingate and create a new one, increasing the size. The ingate has been generated at the YZ plane. Now simply select the element sides and click on Create Mesh. As you can observe, the mesh generated has a poor quality due to the element size we are using. By decreasing the element size and regenerating the mesh, we will obtain a better mesh. We have now a good quality mesh and we are ready to go to the next step. In step number 3, all process parameters will be assigned. First, select the material type for the part. Select a specific alloy and finally define the pouring temperature. The mold material and initial temperature must be defined in the same way. Gravity direction for this particular case will be aligned with the y-axis. It's time to select the ingate velocity. This is a calculation stage. We can choose between calculate only filling, only solidification, or both. It is not necessary to wait until the end of calculation to check the results. Just wait until it has reached the 1%. This is the visualization of the filling results. We can observe a lot of air entrapment during the filling. In addition, there are a lot of turbulences. Taking a look to the results and observing the filling evolution, we decided to change the ingate position and start a new simulation. Coming back to the mesh stage and deleting the ingate and creating a new one in a different position. generating a new mesh, launching a new calculation. Then we proceed to check the new results. Filling evolution, with a double click the part surface becomes transparent. Temperatures, making a cut and adding labels to check the temperature in a desired point. Velocities in isosurface and with vectors, cold shots, air entrapment, mold erosion, filling time, and solid fraction during filling. Regarding solidification results, it is possible to make a graph to see the evolution of the temperature during the solidification, selecting different nodes in different areas of the model. It is possible to change colors and to export the results. The solid fraction evolution shows last areas to solidify. Red areas are liquid before solidification. Solidification times, shrinkage porosity, and solidification modules. Once we have decided this is a good way to fill this part with a virtual ingate, we can simulate the full model with the filling system. This time we will use the automatic ingate, just selecting a surface. And meshing with an element size of 1.5 millimeters. In this step, we will use the two phases velocity. This option is very useful for high-pressure die casting processes and gives us the possibility to use different velocities for the filling. So we can start with a slow velocity of 0.2 meters per second, and when the material reaches the selected point, the velocity will change to 2 meters per second just before entering the part. Launch a new calculation and check the results. We can observe the filling evolution with the filling system added. Regarding velocities, I'm going to select a label at the piston to check the second phase velocity. The filling starts with 0.2 meters per second, and when the material reaches the selected point, changes to 2 meters per second to get more velocity just at the ingate of the model. We have shown some of the possibilities of Click2Cast. Thanks for your attention, and if you want more information, please visit our website.